this is Britt Caswell with another example video. In today's video, I'm covering example 1 from section 7-5 in the SavvasRealize Algebra 1 textbook. The goal of today's video is to understand factoring a trinomial. So before I actually get into factoring, I actually have a couple things I want to discuss with you. The first being this equation here. This is called the standard form of a quadratic. Notice that it is a trinomial. It has a square term, a linear term, and a constant. And it has letters A, B, and C here. So the A, B, and C are referring to the coefficients to specific terms. So if ever you see something reference a B term, it's always going to reference this linear term. Or if ever they're referencing the letter A, they're talking about the coefficient of the X term. So in this section, what we are doing is we are learning how to factor specifically when A is equal to 1. So that's the first thing. So we are starting when A is equal to 1, and in our next section, we'll talk about when A is not 1. Now the other thing is to remind you about what factoring is. So I bring up my friend equation there, 3 times 4 is equal to 12, where 12 is called the product, and 3 and 4 are factors. Okay, so when we are factoring something, what we are doing is we are breaking it up into two things that multiply to each other. Okay. So earlier in this chapter, or topic I should say, we learned how to multiply together two binomials. Right, so I'm going to show it to you guys with the box method just because it's a little easier for students to see. But we learned it with other ways, right? We learned it with the distributive property as well, right? And so when we were finding the area of the box, we were multiplying together the two sides of each square. So x times x is x squared, x times 2 is 2x, 3 times x is 3x, and 3 times 2 is 6. So once we're at this place, right, to find the actual full area, we would write it out as a polynomial where we add each of these things together. So I'd take x squared, and then 2x and 3x, those are like terms, right? So they combine with each other into 5x, and then plus 6. So when we're factoring, what we're doing is we are starting here with the end product, and we're going backwards. We are finding the top and the side of the box. That's kind of our goal. Okay? So part B is asking us to find the factored form here. We just multiplied them together so we know this factored form, but I want to walk you through the logistical steps. All right? So our first step is to go ahead and set up what I call the double bubble. Okay, that's two sets of parentheses. Ooh, I can't spell double today. Double bubble. All right. Next step is to fill in the x. All right. Now here we have an x squared, and we also have a linear term. So that linear term only comes from multiplying an x times a number, right? And the x squared comes from multiplying an x times an x. So on any of these cases where we have a is equal to 1, we will always have an x in each bubble at the front. The next step is to drop down the first sign. So what I'm doing is I'm looking at this plus right here. Let me color him. He falls down just into the first set of parentheses. Our fourth step is to fill in the second sign. Now there's two possible signs here. There's positive or negative. And so what we do is we actually look at the second sign here. So if second sign is positive, you got to match the signs. So because this is a plus, this also has to be a plus. Because here's a plus and here's a plus. These have to match. If second sign is negative, they need to be opposites. So if this second sign, this blue one, had been a minus, I look here, this is a plus, so I need the opposite of that plus. Okay? And that idea is a little harder to see here when it's a plus plus. You'll see it as we do more of these examples. Our next step is to fill in the numbers. So the way that we find the numbers that would go in there is we set up a t-chart. I'm going to do it over here. Didn't leave myself enough room apparently. I shouldn't have put the word second sign in there. So the first box gets a 6 and the second box gets a 5. Alright, so notice that they're kind of flip-flopped, right? So what I'm doing is I'm finding the factors of 6, and then I'm going back to that second sign, and I see that second sign's a plus. So I'm going to add to find what adds to 5. If that second sign had been a minus, I would have been subtracting here. Alright, so now I have to just think about the factors that make 6. Well, I know that 1 times 6 is 6, and I know that 2 and 3 make 6. Now, I put the bigger number first when I write the factors. I'll show you why here in a second. And so I need the ones that add to 5, so I'm going to start adding these. So 6 plus 1 is 7, and 3 plus 2 is 5. So I'm going to be using the 3 and the 2. And when I fill these in, I always put the big number first, which on problems like this where your signs match, it doesn't really matter. But soon we'll get to it to where we'll have like a minus plus or a plus minus, and then it matters what sign you put first, okay? Alright, so let's go through this, try it again. So I start out, I put in my double bubble. I fill in my x's. My first sign comes down. Now because this sign is a plus, that means my parentheses have to match. So to match that plus, I need another plus here. Then I set up my t-table and I flip my 36 and 13. So I'm finding the factors of 36. Because of that plus, they have to add to make 13. Now there's lots of factors for 36. There's 1 and 36, there's 2 and 18, 3 and 12, 4 and 9, and 6 and 6. It might help you to have a multiplication table available in case you struggle with coming up with these factors, which is a thing for many kids. I know with my students, I go ahead and I put a multiplication table in my Google Classroom for them to use. So I went ahead and I added all of these together, and I need the set that equals 13, which you can see right here is 9 and 4, and so that's what I fill in. Alright, so let's go ahead and let's do this again. So I'm going to set up my double bubble. I fill in my x and my x. My first sign falls down. My second sign is a plus, so that means these have to match. I set up my t-table, flipping the 28 and the 11. So I'm finding the factors of 28, and I look at that second sign to figure out if I add or subtract, so I'm adding to make 11. So 28, I have 1 and 28, 2 and 14, and 4 and 7. And when I add, I get 29, 16, and 11. So that 7 and 4 are what I'm going to fill in here. Now remember, this is a type of division, right? because I found the two things that multiply to make that number. So if I want to check and make sure I'm doing this properly, I can actually multiply together these two binomials and make sure that I get the original problem. All right, so this has like a built-in you can check yourself step, which is kind of cool. So there we have it, guys. That is understanding factoring a trinomial. Until next time.